7. Using properties of exponents. Learning target 4. I can recognize taking a square root as the inverse of squaring a number and a cube root as the inverse of cubing a number. So we're going to look a lot at inverses and learning that the inverse of a square root is squaring and the inverse of a cube root is cubing. So what are inverses and their examples? So we'll start back at inverses are the word for opposite. So when you perform an operation and then you do the opposite to undo that operation, those two operations are inverses. So for example, if we take 10 plus 4 and get the value of 14, but then we take that 14 and we subtract 4, we go back to 10. So that we're saying that 4, positive 4, or adding 4, and subtracting 4 are inverses because they lead you back into those same exact values that you started with. Here's another example. Let's go 10 times 2, which is equivalent to 20. And if I go 20, then divided back 2, it goes back to 10. So again, you notice that when you multiply, the inverse is to divide because we started with 10 and we ended with 10. So multiplying and dividing undid each other's actions. So let's look at squaring and square rooting. So we're going to start with the example of 5. So if we start with 5 and we square it, we get 25. And if we take that 25 and we square root it, it goes back to 5. So notice that squaring and square rooting went back to those original values. Another example, if I take, let's go 6 and I square it, is 36. If we take that 36 and we square root it, it goes back to 6. So notice again, square and square rooting undo or are inverses of each other. Same thing if we cube. Okay, so let's say we have the cube root of 64 is 4. So if we took 4 cubed, it's 64, and then we cube root that 64, it goes back into 4. Or 5 cubed equals 125. So the cube root of 125 goes back to 5. So notice again that if we cube and cube root, we undo the math. We undo the inverse of those operations. So let's look at examples. So let's say we have the square root of x equals the positive or negative 12. Well, if I need x by itself, because that is what we would do to solve it. So if we get x by itself and we have a square root, that means I'm going to undo the square root by squaring. And if you do it to one side, you have to do it to both sides. So if we check our math here, x equals 12 times 12, which is 144, or negative 12 times negative 12 is also 144. So I can conclude that x is equal to 144. Another example, let's do a cube root. So the cube root of x equals 2. So to undo this cube root, I'm going to cube, since that's my inverse. So if I cube one side, I must cube the other side. So this leaves you with x, since these undo each other, and 2 times 2 times 2 is equivalent to 8. So x is equal to 8. A couple more examples here. Let's say the square root of x equals negative 8. So we're going to undo the square root by squaring both sides. So this leaves me with x, and now I have negative 8 times negative 8. So x is equivalent to 64. The square root of 10, I apologize. Square root of x equals 10. So we're going to square to get rid of the square root to make the inverse, which would leave us with x because these cross each other out or inverse each other. And 10 times 10 is 100. Two more. The cube root of x equals 1. So we're going to cube, because cube rooting and cubes are inverses, which means they cancel each other out. And 1 times 1 times 1 equals 1. So x equals 1. And the last example of this would be the square root of x equals the positive or negative 9. So to undo the square root here on this x, so x can be alone, we're going to put an x here. We're going to square both sides. So 9 times 9 equals 81. And negative 9 times negative 9 equals 81. So we conclude that x equals 81. Let's finish up with a couple of true-false statements. So we have the cube root of 8 is equivalent to 2 squared. We're just going to solve here. The cube root of 8 is 2, and 2 squared is 4. So we can say that these are not equivalent, so this would be a false statement. And one more, the square root of 16 equals the square root of 4 squared. Well, the square root of 16 is 4. And if we go over here, the square root and the square cancel each other out, which leaves you with 4. And 4 equals 4, which is true.